Welcome to the fourth video of a series of 8 on rational expressions. Division. Before we can get to an actual division problem that you might see in a mathematics course, let's review a reciprocal rule for division that we're going to be using in this video. Here's a reminder. Suppose we have a fraction divided by a fraction. Now before I start this is not an example that we'll be doing in most algebra courses, but this is a reminder from middle school or elementary school of how the reciprocal rule works. So suppose you're dividing a fraction by another fraction. What you do mechanically is you replace the division with multiplication, and you take the reciprocal of the divisor. In other words, as a fraction, you flip it over. Now this doesn't give you an answer, but it changes a division problem into a multiplication problem. And then we can use our fraction multiplication skills. In this case, there are a couple of options, one of which would be just to multiply the tops together. 3 times 2 is 6, and calculation will show 7 times 15 is 105. Or you could cross-cancel the 3 and the 15 instead if you know that trick. Either way, after reducing, you get an answer. Now, the focus here is not as much the answer as it was just a means of me showing you the reciprocal rule, which we will be using in our algebra problems. So, this problem here that we just did, in an algebra class, you're more likely to see it looking like this. In other words, this division symbol here is not something we routinely use in algebra. It doesn't make it wrong, it's just not tradition to do that. So let's take the same problem rephrased and see what it would look like in an algebra context. It's the same problem, I'm just giving you a different view of it. Here we're dividing fractions, we change division into multiplication, take the reciprocal of the bottom, and then do the multiplication problem as we always would. So now that we have the reciprocal rule under our belt, let's look at an actual division problem that we might do in an algebra class. Here we have a rational expression divided by another rational expression. Before I do this problem, let me remind you that in some contexts you'll see this same problem look like this. That's not my style of writing it, but you may see that with other professors or on other websites. Same problem. Okay, the first thing you do with a division problem, one rational expression divided by another, is you multiply by the reciprocal of the divisor. Let me say that a different way. I changed division into multiplication, and I took the reciprocal of the divisor, or what I was dividing by. Now we don't have an answer this way, but what that does is it converts a division problem into a multiplication problem. Now I've produced a video. You may have just watched it if you're watching these in sequence. Our third video was about multiplying rational expressions. Well, we've turned this division problem into a multiplication problem. From this point on, nothing is new. We're going to use the techniques of the last video. If you didn't watch it, I'll remind you, or tell you, that we're going to factor everything, and then we're going to interchange our factors to make ones, as we call them. Expressions whose value is almost always 1. Let me show you what I mean. Here I've factored everything. Here I've rearranged the order of the factors. I haven't changed the numerator or denominator. I've just broken this product of 2 fractions into a product of 3, because you'll notice here at the bottom line of your screen, the second and third fraction both have a value of 1, using the fact that anything divided by itself is 1. So these change into 1s, and then using the rule that 1 times anything is itself, we have the answer, or the reduced version of this problem. Here's another example. Now we actually saw this back in video 1, and it was claimed in video 1 that the reduced version of this division is 5x over 2. Now let's look at the details that I omitted in that video. Okay, first, before we start the problem, let me change this division format into the one that we'll be using. And now let's go through the same process. Step 1, change division into multiplication and take the reciprocal of the divisor. Now I just have to do this as a multiplication problem, which as we've seen involves factoring. Notice I've factored everything here. But I'm going to make one other factorization here. Do you see the x cubed? I'm going to factor x cubed into x squared times x. Now, I wouldn't always do this. There are times where I wouldn't bother. But in this case, I think it's a clever move because it will allow me to pair up these x squareds later and make a fraction whose ratio is 1. Okay. Now that I've factored everything, I simply rearrange the factors. Now this may look totally different to you, but if you pause the video and look, you'll notice that I haven't changed anything except the order of the factors and broken two fractions up into a product of 3. But I've done it in a clever way. Notice in the bottom line on your screen, the second and third fractions are both 1. Using the rule that anything divided by itself is 1, these become 1s, and then the rule 1 times anything is itself gives me an answer of 5 times x over 2. There's nothing wrong with this answer, but as an afterthought, notice the times sign between the 5 and the x. There's nothing wrong with keeping it there, but 5 times x and 5x mean the same thing, so I'm going to take the simpler version of that. Notice we did in fact get the answer that we claimed we would get in a prior video. And that completes the 4th of 8 videos.